Hello and good morning and welcome to our presentation on SolidWorks Electrical. My name is Shane Devaney and I'm an account manager with SolidXperts, and doing the presentation will be Chris Duchesne, our applications engineer.
Thank you very much, Shane. So today we're going to be talking about the new product SolidWorks Electrical, which is a new product that SolidWorks offers now to be able to give intelligent design to schematics and the 3D world. So first we're going to start off with, we have a packaging line here, and we're going to go ahead and we're going to design a system with an electrical enclosure and then do the wiring internally, as you can see here on the internal devices here with a PLC and circuit breaker to internal blocks, and then we're going to wire in a motor. Now, how SolidWorks Electrical works is it actually works in between the 2D and 3D world. You have a 2D schematic software, which you can see here, where you have access to different parts of the schematic of line diagrams, actual schematic pages with different motors and designs, as well as actual reference documentation that you actually place in the schematic for like the different motors you'd use or breakers. But that same information is also available in the 3D world, in the 3D side of it, where if I go over here once again to my panes here, and I can actually access the exact same reference documentation that you saw for like the motor we would use, as well as I can access my line diagrams from both the 3D world and the 2D schematic world, and they share the same data and information as you work, and they'll update simultaneously as you're designing. So for this project today, we're replacing a motor, connecting some internal blocks, and then I will place the breakers to the contactor, to the internal blocks in the schematic, and then lay it out in the panel. Then I will also be adding circuit breakers and a power supply to power the PLC. So let's go ahead now and go to SolidWorks to start with, and let's go ahead and place our motor in the SolidWorks world. So here I have my packaging line, and then here's the panel I'll be working with for this design. And as you can see, there's some components missing. I'll be laying out with the related wire, and then but before we can start doing the wiring of the panel, we first got to place the motor in our design. So I'll go there in our schematic to our motor location, and I'll use SolidWorks to place that motor on my design of my 3D part. Now that motor has been placed, let's go back to the 2D schematic to lay it out. Now, whenever you're designing layouts and different motors and designs, you can actually do a single line diagram, as you can see here, and actually add the intelligence to this. And you can actually use pictures and photographs to really easily illustrate what you're trying to do. In this case, I'm going to go ahead now and remove my graphic for my motor, and now we're going to actually place a real symbol in there as a placeholder. So I'm going to go to my line diagram symbols, and then as you can see, it remembers where I had what I asked to use last time, and I can easily access and select which component I want to place. In this case will be the motor, you see, and I can just go ahead and just place it nice and quickly in the diagram. Up comes a properties box where I can enter in specific information or what type of description I want to give it. And then I can also go through and then specify the location where this is being used, which will be used on the other conveyor components. And once I okay that, then it'll automatically place my motor in my single line diagram. Now that I've done that, let's go ahead to our power page here and actually go through and lay out the actual individual schematic details. Now I could actually, if I wanted to, select and copy and paste this information to reuse it again and re-establish the references, but in this case, in this example, I'm going to go through and build it from scratch. So, first thing we're going to do is we're going to need our motor. So let's go insert a symbol, and let's go to our symbol library and we'll grab our motor. motor we're using, 3-phase. Select it, and we'll go ahead then and proceed to place that in our schematic, and then specify which motor we're going to use. In this case, I'm going to use a 5, which we've already inserted into our design, and then I will reference that. So now I'm referencing that motor. After I place that, we got to wire it. So I'm going to go over here to my multi-conductor wire connection, and then you can use these several conductors. Now the thing is, you can specify what type of wire you're using. Once again, in the panel design, you have 24 volt DC control voltage for control your I/O and stuff. You also have your 480 or 120 for like running your common plug products. For this case, for motor, we're going to be using 3-phase connection with line 1, line 2, and a neutral. So I'll go ahead and select that wire to place, and I just specify the connectors to pull from. Select it. Select where I'll start placing it, and just drag it out and connect it to my motor. So now these wires have been connected to my motor, and now I'm going to go through and I'm going to actually add the manufacturer of this motor of what it actually made. So I can go to my manufacturer here. You can see the connections I just placed. Those wires are automatically called out. So now I'm going to go search and specify what type of motor I want to use. I can select from a very large library of motors we've created. In this case, I'm going to go with a Warren Summer motor base. Then I can type in the different reference numbers for I'm going to use an LS, and as you can see, the list sorts automatically based on that to help refine. If I want a 112, the list will further define it, so it'll narrow down my selection quickly. So I'm using the LS112M with a 4-pole, and as you can see, it automatically takes my terminal connections and relates it to my wiring, and it's already showing green, so it's already resolved it. And then I'll go ahead and add that to my motor symbol, that part, and as you can see now, when I OK it, it actually drops in the motor information for that. There. Now after I have applied that, now we need to add these other components to it. So let's go ahead and add our protection here for the motor. So I'm going to go once again to insert symbol, and I can go from insert symbol, or I can actually go from our nice search library, and I can actually actively search. So I'm going to search for a 3-pole device, which is for this motor. So I can go through the symbols, and here I have a 3-pole circuit breaker resistor, and I can just go ahead, click electromagnetic, electrothermal, and then I can just drag and drop it on, write my schematic, and it'll go ahead and place that information. And now I can go through and then specify what I want to lay it to, either a new number. In this case, I already know I have that component already exists, so I'll just be going to Q4, then for my line diagram, and then I will reference that, and now it's referenced to Q4, my line diagram, and the information will populate accordingly from previously the manufacturer and device tag. Now I can go ahead and do that again here. In this case, I'm just going to do a good old-fashioned Windows command, copy, Control-C, and paste, Control-V, and actually place that in line. And then just as before, I'm going to go ahead and reference my symbol. And because I already have it in my line diagram, I can actually specify an address to K4. And then after I do that, make the reference, and as you can see, it automatically fills out the description material that's been applied on my line diagram, and it's all associated to that. Now the next thing I'm going to do is, obviously, as you can see the motor up here, I have to make the connection between them. So I need to add terminal blocks. So now I'm going to go up to and insert terminal blocks to this, and I'm just going to draw multiple terminal blocks. Just draw a line in, across my wires I placed earlier. And I just specify a direction, interior and exterior reference. Pick which terminal blocks I want to place them on. This would be X1. And after I do that, I'll go ahead now and I'm going to place those terminal blocks, and we'll go ahead and add them automatically and place them in line. Now, once these terminal blocks are placed, I need to go ahead and let's add the materials to reference them. So I'm going to edit my terminal list. Then as you can see down here, my terminal blocks I just added, 17, 18, 19, and here I have an existing block. So let's first add them, add a part to it. So we go through my Wago list, and I'm going to use the same one I used in my other blocks earlier. So it's going to be my 1201 Wago. I'm going to go ahead and add that to my terminal list. And when I select it, it'll automatically populate that in. And finally, for my ground PE block, I am going to assign a part of 1707 for that to be added. So when you assign it, to make sure when you make the selection, you have to add the block. I forgot to make the pick. Now I just go ahead and hit select. Now I have added to my list. So now my actual wire connections has been associated. Now that takes care of my terminal block side. Now I need to associate a cable to this, because once again this is exterior wiring going out to a motor. I'll go ahead and select that, and I'm going to assign a cable. And the nice thing is, we can select where the cables are going. So this is going to, our first location is L11, the enclosure we're currently in, to location L4. Now we can select from our list. Now, if you can see through the different cables, when they're in blue, that means the cable's been assigned to, already assigned to connection to from connection. Where here under W10, this cable has not yet been assigned yet. So I'm going to go through, select those conductors, and now I'm going to assign them to the terminal blocks and motor we just placed in the schematic. So now I just added that cable, so now this has been assigned to the new motor I just placed in the schematic. So now if you close it, you can actually see I have my new cable that was assigned to between my motor, my terminal blocks, and the enclosure. So if I go further down in the schematic, you can actually see the color, the actual conductors have been applied, W10, and the colors they associate with accordingly to those terminal blocks. So that takes care of my motor connection. Now, if we go back to our line diagram, we just need to place the connection between the motor and the terminal blocks to specify that as existing in our line diagram. Now, if you see the motor, it also populated the material motor, the wattage, and the specifications actually in our line diagram related back to the actual detail schematic for our power. Now, that's done. We've taken care of this one leg of the system. Now let's go ahead and take care of the power for the PLC, which we'll place here in our power distribution schematic here down below. But we've already actually used this in a previous design, so if I go back to my palette display, I can actually go here to my power, and actually I can see where I've actually previously used it. But I want to reuse this again, but in my other enclosure for my palette line. The nice thing is with SolidWorks Electrical, you can very easily redefine the schematics you have to actually do this and create a quick group or macro that you can copy and paste in any system or save to use in future designs after you standardize your parts and process. So now I'm going to go ahead now and select the wire, and as soon as I'll select the entities I want to copy, make it to a macro, just drag, drop it in my macros, and as quick as that it gets applied, and SolidWorks will add that exact wire and component combination to my macros, and now I can go ahead and go back to my package line schematic, power page, and be able to use that exact macro, and it's as simple as drag and drop it in. So it's very easily to create new combination of components on the fly from previous schematics and reuse old work without having to do it over and over again. So now I just place my I just placed my new components in and automatically increment them. So I just want to reference it to parts of my existing line diagram in these palette lines. So I'm going to go ahead now and assign a component, which will be Q6. Q6. Assign that, and then I'm going to go through, and after I assign that one, go to my transformer here, and then assign that to T1. It's assigned, and the material populates automatically, so now I have it assigned to T1, T2, and that should take care of my power distribution phase. Now, whenever you design electrical components, you have a multi-page schematic. You want to be able to continue the wire connections from one page to another for continuity, or to know where your potential of your electric wiring is going. So we have a thing we use called managing destination points. So if I click destination points, it'll automatically relate this to a schematic that has the destination points currently being sent off. So I have for my transformer here, I'm going to put destination points from here to power my PLC and the common for the PLC. So all I have to do is go ahead and click destination point, select my start location, select my end location, and I'll place it. As you can see here, it says page 7 on line 1 and row 1, and as you can see here on this schematic, same reference does page 5, row 11. So these two are tied together to reference. So I'll do a similar thing here. I'll go ahead and place my single point, start here on for my common, and then I'll place it over here to my other side schematic, and as you can see, it automatically applied it, and once again, this is referring back to the same schematic, just on row 12, and this refers back to the exact same location. So once I've placed those, insert those destination points, you can easily use them to travel around schematic because it's completely associated. So if I want to actually go to that location, I can do a go to, and it'll jump me right to that part of the schematic where it's being used. So now we've gone through and placed our components. We get the power supply together. We powered the PLC. Now what we need to do now is we just need to go through and start getting things finalized for the schematic for our reports. Where I would find that is in the projects. You have reports where basically you can specify different types of wire combination, like wire and cable lengths. You can also specify wire numbering or designations for the wires, and generate a report on the fly about this. So I'm going to go through now, and I'm actually going to go now and add to my wire list. So go to process, generate wire numbers, yes, and it'll go through the whole entire schematic and automatically generate all my wire numbers. So if I go to my powers page, they're actually all finally labeled and laid out, which wires are used where, which makes it easier to define and relate to them. And then if I go to my reports, then I can actually see in my reports that all the wires have their labeled accordingly to which wire number refers to which component. And I can also take these lists and print off several copies of it as it changes. Now that's done. So we have our wires labeled, but sometimes we need to know that our wires are actually, you like to know, it would be nice to know the lengths, how they're being used. And we have some given lengths here, but we want to know exactly, but it would be nice to know what the actual lengths are in the 3D world. That's the great thing about SolidWorks is now we can now take our 2D information we just entered to create the schematic And now go to the 3D and go back to the main enclosure. And let's lay out some of the components we've been creating here with SolidWorks Electrical. Lay out what's been going on in our electrical enclosure 1. You can see where we have some devices already laid out and panned to it and has already been created and it's already been placed. And then let's go to L11, which is our back panel here. Now, there are components that still have yet not been placed. So let's start off with our terminal list here that we've added blocks here, and let's insert this group. So now we'll go ahead and insert this on this terminal rail. We'll go ahead and place this component here. And now when we place the component in SolidWorks, it automatically references mates to know that it's mounted on a DIN rail. Then once we place it on DIN rail, we can specify distance spacing for the component we're inserting. Or we can just go ahead and I'm just going to go ahead and insert it with what it has. And then they'll go through and place all my parts from my schematic that would define that terminal block rail of X1 on my schematic and put them in place, both my ground blocks and my distribution blocks all together, as you can see here. Now, let's go through and see which components have not been placed in the schematic just yet. So we can actually hide and see what still need to be inserted. So let's insert some more components. First thing I'm going to insert next is I'm going to insert all the components that were from my line diagram of my circuit breakers and my transformers and everything that were on my power page. So I'll go ahead and select all those and I'll insert them in all at once. And when you go to insert them in, you can actually specify a specific order how you want them placed. In this case, I want to put my transformer here, and I want to move it to the middle of this group of the breakers and control contactors are being inserted. So once I am happy with my list, I can just go ahead and hit OK. Then I'll go through and give me a nice preview of a single part. So I'll just go here in the second terminal rail, we'll get it lined up about kind of the area I want to place it, just pick it, and just as before I did with the terminal blocks, it'll automatically made it in place with mate references to automate and make this process simple. Just as before, I can specify a distance between the individual multiple components. In this case, I'm going to put 12.7 millimeter spacing for heat reasons. You know, with contactors and breakers, they need to have some thermal room so they don't get too hot. I'll go ahead and place them, and that'll go through and place all those components I selected automatically, given the space I actually applied in the 3D world. And when it's all done, all my components are placed now in the schematic. If you need to move around a little bit, you can, and add more references to help nail them down further. So now that we have our panel all laid out, most of our components, let's go ahead and major components, let's go ahead and add a few more other things that we're missing. For example, there's, let's refresh this. We have our door, we still have one light switch that has not been placed. So just as before, we can right click, insert the component, and we just have to bring it around to the front door here, drag and insert the row that's being used, place it, as for a mate, say it's going to be mated there. And a really great feature is we have the capabilities here to actually insert a mate feature, so you can actually insert detailed information of a feature. So this actual light will actually cut itself its own hole, and as you can see here through the smart features, I'm going to actually just need to select the face to apply it, and it will actually cut out its own hole in the front electrical door being used here. This example. So if I open the door, you can actually see where it actually placed that hole. So let's go back to our enclosure we're working on. Now we got all our components, pretty much most of our components placed and everything for this design. Now let's go ahead through and run our route to route all the components together. So the nice thing in SolidWorks, I can go to route wires, and I can specify if I want to use a 3D route, 3D routing, which will actually give you the real diameter of the wire and spaces and give you a true 3D design. But that takes a little while to do when you're running a fairly large, complex enclosure like this. So in this case, I'm going to use sketch route to kind of give a quick update to show what's going on. Use splines for all my components, and then after that, you can specify the type of parameters of how much bend you're going to have between transitions, and also you can also specify the distance between the connections and the space between the wires. So now I'm going to go through and run this routing, automated routing with the schematic, where it's going to go through now and use all the schematic information I just got done entering in earlier and bring it into my 3D world here and automatically route all these components together with no hands. And it's able to use the intelligence of the schematic to place all my components and interconnect, wire them together, and get the right wire type, size, color, and even all the way down to if it's going to be a ground wire or is it going to be a power wire, and the size, all from the information we entered in the schematic. And here we are. We have a fully routed enclosure here with all our wires laid out in different directions accordingly for signal and control. And the beautiful part about this is once you have routed all the wires together, you then can actually go back to the electrical 2D schematic now and recheck your reports here. And now we can actually have specified lengths for all our individual wires that now you can print this off, report off, and people can cut the wires to length and how it's being used in the actual enclosure. So once again, with SolidWorks Electrical, it gives you the flexibility and added capabilities to really maximize your power of running routes and be able to create 2D schematic geometry on the fly, cut down the amount of rework and time it takes to build the design.
Hi, Chris. Thanks for that presentation. It was awesome. Learned a lot, and I hope everyone watching did too. If you have any questions, feel free to go to our website at www.solidexperts.com, or you can email me directly at sdevaney@solidexperts.com. Thank you, and have a great day.